Here's 1.4, day 3, question number 3. So we're going to use elimination to solve this system. And so the variable we can choose to eliminate is either x or z. That's what's suggested here. So let's go ahead and go with x. So I'm going to choose the first equation, and with that first equation, I'm going to add it to the second equation. So the reason why is because our x's have the same exact coefficient of 1, but 1 is opposite. So when I add it together, then the x will go away. So let's rewrite it. The x's cancel, so we get 3y minus z equals 7. So we've used the first two equations. We have to use the third one for our next one. And if we're trying to eliminate x again, then a good one to use would be the second equation. And the reason why is because they're opposite signs. And then for the second equation, all I need to do then is multiply by a positive 2. If I multiply by positive 2, then this will be a negative 2x and then a positive 2x. And so those will cancel. So let me distribute a 2 into the second equation. And then let me rewrite the bottom equation, 2x plus 3y minus z equals 9. And then now we'll add that together, so we get 7y plus z equals 13. So that is step 1. Step 2, we're going to solve for two variables by using the elimination method. So we have y and z, and so in this case, if we add it as they are, we have a negative z and a positive z. So therefore, when we add them, the z will disappear. So we're just going to go ahead and rewrite the equations here. 3y minus z equals 7, and 7y plus z equals 13. So z's cancel. Then we get 7 plus 3 is 10y equals 20. Divide by 10. Then we get y is 2. Now that we know that y is 2, we're going to solve for one of the other variables by substituting it into one of these systems of 2. And it doesn't matter which one. So I'll go ahead and substitute it into the top one here. So this is 3 times y, which is 2, and then minus z equals 7. So 6 minus z equals 7. Subtract 6. We get negative z equals positive 1. But z needs to be positive, so let's divide by a negative 1. So therefore, we find that z is negative 1. So now what we need to do, now that we know y and z, we're going to plug both of those into one of the original equations at the top to solve for our final variable x. So I'm going to use the top equation, x plus y minus 2z equals 5. So I'll write it here, x plus y minus 2z equals 5. And so now we're going to substitute our y and our z. So x plus y is 2 minus 2 times negative 1 equals 5. Then we still have our x plus 2, and negative 2 times a negative 1 is a positive 2 equals 5. So we add 2 and 2 together, we get 4 equals 5. Subtract 4 from both sides, you get x equals 1. So the last part is to write it as an ordered triplet, so x, y, z. X is positive 1, y is 2, and z is negative 1.